Okay, so for lesson 8, we are trying to find the diagonal through that cube going from one corner to the other. It's a 3-dimensional diagonal. So what we need to do in order to find that diagonal is we need to first use the Pythagorean theorem to find the length of the diagonal of the base. So first you're going to find the length of the diagonal of the base using Pythagorean theorem. Okay? So Pythagorean theorem is going to help us find the length of the diagonal of the base. That's the line that you drew across the bottom of your cube. After you find the diagonal of the base, you are going to use that length as one of the legs. So use the length in step 1 as one of the legs. And the vertical edge is going to be your second leg, so the height. Okay? So the diagonal that I drew and the height is going to be my other leg. And then you're going to use Pythagorean theorem again, which is going to help you find the length of the diagonal. So we're actually doing Pythagorean theorem twice. If you are doing your Pythagorean theorem and your answer does not come out to be a perfect square, I want you to use a calculator and you're going to round to the nearest tenth, okay? So I want to find the diagonal from this back corner to the corner in the front. So I'm going to draw that here in red. So this is the back corner, and I want to find the diagonal going through the prism all the way to the front. So it's not a flat line. It's that 3D diagonal going through the prism. So draw that. Now, in order to do that, I need 2 legs for Pythagorean theorem, but I don't have 2 legs yet. One of my legs is the diagonal going across the bottom of the base. So I need to draw the diagonal going across the bottom of the base. Now, what might help you all visualize this a little bit is to draw the dotted lines to indicate where the spots that we can't see. So you're going to go from this back corner and you're going to draw a dotted line straight down. And then from the back of the base, draw a dotted line across. And where the 2 meet, you're going to draw another diagonal dotted line. So that way we can see this is the base across the bottom. This is that back edge that we can't see. Okay? So you want to draw the pieces that we can't see because it's a solid. So this green diagonal across the base, that's one of the legs of our 3D triangle. So how can I find the length of the diagonal across the base? We can use Pythagorean theorem. Actually, let me use green. We can use Pythagorean theorem here to find the length of the base. So let's call the length of the base C, and let's use Pythagorean theorem on C, or to find the length of C. So we are going to have 8 squared plus 6 squared equals C squared. Will you guys find that for me right now? All right, guys, so what did you get for 8 squared? 64 plus what? Good, 36 equals C squared. What's 64 plus 36? 100. So 100 equals C squared. So when I take the square root, I get C equals what? 10. What I want you to do is label that right here. C equals 10. So we know that that diagonal across the bottom, this part right here, is 10. Now I have 2 legs. This diagonal is one of my legs, and what's my other one? 24, the edge or the height. So we're going to do Pythagorean theorem again, and that's going to give us the diagonal through the prism. So we're going to do Pythagorean theorem again. 10 squared plus 24 squared equals, what do you want to call this? Let's call it D for diagonal. Equals D squared. Okay, so let's see what you guys got. 10 squared gives me 100 plus 24 squared is? What'd you get? 576 equals D squared. 100 plus 576 gives me 676 equals D squared. Square root both sides, and what do I get? D equals 26. So D equals 26, and that is your answer. How many of you got that? Good. So when you're looking for the diagonal of a three-dimensional object, we have to take Pythagorean theorem twice. Let's do it one more time with an example that won't always work out so nice. So example 2, you're given a little bit bigger box, and our lengths are 12, 4, and 6. So remember, I want you guys to draw the box so that we can see the sides that are on the other side. So you're going to do a dotted line from the back corner straight down. And from the side, you're going to go straight across. Where they meet, we're going to go diagonal down to the bottom corner. So we can see our base, and this is that back edge. Okay, let's draw the 3D diagonal that we're looking for. We are looking for the diagonal from this back corner all the way down to the front, down here at the front. I have one leg that's 6 centimeters, but I need to find the other. So I need to do Pythagorean theorem across the base of the bottom to find my other leg. So what I want you guys to try right now is find the base of the diagonal of the base. Use Pythagorean theorem to find the diagonal of the base. If you have to use a calculator, you may use a calculator. How did you find the length of the diagonal across the base? 12 squared plus 4 squared equals C squared. Okay, ladies and gentlemen, what's 12 squared? 144 plus 16 equals C squared. So we get what? 160 equals C squared. And when I square root, 160 is not a perfect square. So when you plugged it into the calculator, what did you get? 12.6? Thumbs up if you agree. 12.6? Okay. So now we know that this guy is 12.6. How can I find the length of the diagonal now? So this is one of my bases, or one of my legs, I'm sorry. What's my other leg? 6. So we have to do Pythagorean theorem again to find the length of the diagonal across the prism. So now you're going to use 12.6 as one of your legs and 6 as your other leg. Plug it into the Pythagorean theorem. All right, so we're going to have 12.6 squared plus 6 squared equals, we call that diagonal D squared. What did you all get for 12.6 squared? 158.8. Okay, yeah, make sure that you round correctly or your answer is going to be off. So remember, you need to, if you always look at the one to the right. If it's 5 or greater, you round up. If the number to the right is less than 5, it stays the same. Plus what? 36 equals D squared. What's 158.8 plus 36? 1 what? 194.8 equals d squared. And then last step, you're going to square root. So we get d equals to the nearest tenth what? 14.0. And there you go. Yes, to show that we're rounding. So put the 0.0 to show that we're rounding. Okay, guys, so we can actually estimate what our answer is going to come out to using a shortcut, because let's think about what we're doing here. We are taking, what's a different color? So, if you guys notice, we did Pythagorean theorem how many times here? Twice. And so that means we took 12 squared plus 4 squared, and that gave us this answer, right? But then we took this answer and added what? The 6. So really, what are we doing here? We're taking 12 squared plus 4 squared, which gave us that, right? So 12 squared plus 4 squared was equal to this squared, and then we added 6 squared. So what is the shortcut? The length of the diagonal. Let me erase that. So let's do length of 3D diagonal equals the square root of the length squared plus the width squared plus the height squared. I would put a big box around it. This will work every time. You still want to round to the nearest tenth when you have to. But if you think about it, the first time we took Pythagorean theorem, it was length plus width squared, and that gave me c squared, the diagonal, right? Then we took the c squared, which was length plus width squared, and added the height squared. And then we took the square root. So basically this is putting both steps of Pythagorean theorem, doing it twice, into one. So you can take length squared plus width squared plus height squared, square root it, and that's always going to give you the exact same answer, because that's exactly what we did. We did Pythagorean theorem twice. Does that make sense? So we're going to use this formula on the previous example. So with example 2, we're going to take, let's still call it d squared for diagonal. So d equals the square root of, what was our length, guys? 12? What was our width? 4. What was our height? 6. Okay, so the diagonal equals, what's 12 squared? 144. Plus, what's 4 squared? 16. Plus 36. So the diagonal is the square root of, will you add all three of those numbers together? Tell me what you get. 196. Now, what do you get when you plug in 196 to the calculator?
14.
What did we get on our answer last time? 14. It's the exact same process, just a shortcut. I just wanted to show it to you the long way first so you understand what was going on, but we can use the shortcut now.